Hi there, in this video we'll learn the second set of rules of differentiation. We are going to study the sum and the difference rules of differentiation. As the name goes, sum rule is based on some sum of functions and difference rule is based on some couple of or more than two functions that are being subtracted. So we assume that there are two functions, that is f function and g function, and both are differentiable at x, that is they are continuous and can be differentiated. Then the sum of these two and the difference of these two will come in this form, and we can take the derivative. Here you can see this is the function in which the two functions are being added and subtracted. We take the derivative will appear on both of the functions. It means that the individual derivatives will be calculated and they will be added or subtracted as the situation is. Then we have the Leibniz notation of the derivative when we are using the sum and difference rule. You can see this is the general form, this is the general formula, derivative of the two individual functions separately and then adding or subtracting it accordingly. So this is the first part, the first function and the second function. You can see the first function is separately differentiated and the second function is separately differentiated, and the plus sign is retained. And then you can solve this, take the derivative. Here you will apply the power rule, here you will apply the power rule again, and you will get these two answers. That is 8 into 3 will become 24, 1 reduced from the power will become 8 into 7, and the derivative while keeping x raised to the power 1 will not affect the answer. Here we have already calculated this part in our power rule tutorial. So here we are going to borrow that result. You can pause the video and try to do this. So after this there is another possibility that the two rules are combined. For example, if two functions are being subtracted and one of them is being added into the third one, it means that there will be subtraction rule or difference rule here, and here it will be sum rule. So we will do it in the same way, that we will take the individual derivatives of the three functions or four functions or two functions as the case may be, and we will then add them and subtract them as per the signs of the original function. So in this way we can easily calculate the derivative by applying the sum and the difference rule. Now we will do an economic application of this sum and difference rule. Here you can see that numerical analysis is done for the cost function. Here we are given the cost function, it's a cubic function, and we can calculate the marginal cost by taking the first order derivative, because the derivative of a certain function will give us the slope or the marginal function. So here we are, the derivative is taken on both of the sides with the independent variable, which is q. So you can see it is d over dq. dq is appearing in the denominator. Now this is an interesting situation because there is a negative sign. So these two functions are being subtracted. These two functions, they are being added, and these two are also getting added. So it means that a composite situation will be there. We will apply the difference rule as well as the sum rule simultaneously in this situation. So the derivative of q3 is calculated, derivative of 4q square is calculated, 10q it is calculated, 75 it is calculated. The derivative of it will be 2q and 3q square. So this 3q square is written here. The derivative in this case will be 8q, and it is written here. 10q, its derivative will be equal to 10, and the derivative of a constant, for example 75, will be equal to 0. So now we have a marginal function of the cost function, and it is the value of it. This is actually the marginal cost function. We have plotted this as well, the slope of the cost curve, rate of the change in the cost function. So here the output and here the marginal cost is placed, and the marginal cost basically is the rate of change. So you see that it has a positive relationship As there are more outputs, there will be an increase in the marginal cost. That may be not a straight line, but it will be there, and that will be a substantially notable cost curve, and it's a positively related situation. So this is how we can make this. So now if you have a cost function, you can easily calculate the marginal function from it simply by taking its derivative with respect to the given variable. For example, it can be q or any other variable. So this is the summary of the sum and difference rule that we understood here, and we have done this with the help of an economic example as well, in addition to the mathematical examples. Thank you.